Hi students, welcome to the fourth lecture in permutations and combinations. I hope you have watched the first three lectures. Else, watch the first three lectures in order and then come to the fourth lecture. So in this lecture we are going to see few more problems related to permutations. Before going into the details of this lecture, let us recall what we have done in the first three lectures. So in the first three lectures we have defined fundamental principle of counting, both multiplication and addition. So let me recall that for you. If a task T can be divided into two works, W1 and W2. And W1 can be performed in M ways and W2 can be performed in N ways. And the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is equal to M times N. So what you have to understand here is whenever end comes, we'll have multiplication. So here the task is divided into two works, W1 and W2. And W1 can be performed in M ways, W2 can be performed in N ways. Therefore, the number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is equal to M times N. And then we have this addition. So a task can be performed in two formats, W1 or W2. And W1 can be performed in M ways and W2 can be performed in N ways. Then the total number of ways of completing the task is equal to number of ways of completing W1 plus number of ways of completing W2, which is equal to M plus N. So in the previous one, a task is divided into two works, W1 and W2. So here we are performing both W1 and W2. In this one, a task T can be performed in two formats, W1 or W2. Therefore, the number of ways of completing the task is equal to number of ways of completing W1 plus number of ways of completing W2. So you have to understand the difference between these two. And then we have defined factorials. I think by this time you are familiar with factorials. 0 factorial is defined to be 1 by convention, and then if n is a positive integer, then n factorial is equal to n times n minus 1 factorial. Or else we can define 4 factorial is equal to 4 times 3 factorial, or else which we can write it as 4 times 3 times 2 times 1. So this is the way we define factorials. So we start with that number and we keep on decreasing that number until we hit 1. Okay, and then we have discussed about linear permutations and circular permutations. If we arrange things in a row, then it is going to be called as a linear permutation. If we arrange things in a circle, then it is called a circular permutation. And we have seen few differences between linear permutations and circular permutations. The main difference in linear permutations and circular permutations is in linear permutations we have the notion of first place, second place and so on. But whereas in a circular permutation we don't have the notion of first place, second place and so on. In a circular permutation, how the elements are positioned with respect to a single element is going to be mattered. Whereas in linear permutation we can directly mention the position. And then we have seen a result to count number of linear permutations of n distinct objects taken R at a time. In general, we denote the number of permutations of n distinct objects taken R at a time by npr or n of p comma r. But mostly we will be using npr notation. So we have to read this as number of permutations of n distinct objects taken R at a time. And the number of permutations of n distinct objects taken R at a time is given by n times n minus 1 times n minus 2 and so on up to n minus r plus 1. And then we can write this in terms of this formula, npr is equal to n factorial upon n minus r factorial. And we have seen how we got this one. And then we have seen few results based on this NPR. So the first important result that we have is NPR is equal to n times n minus 1 p r minus 1. So we have given two different proofs for this one. So one proof is based on the formula and the other proof is based on some combinatorial arguments. And we have one more result, that is NPR is equal to n minus 1 PR plus R times n minus 1 P R minus 1. So here R times n minus 1 P R minus 1 stands for number of permutations of n distinct objects taken R at a time, which always contain a particular element. And here NPR stands for number of permutations of n distinct objects taken R at a time. So here n minus 1 PR, in general it stands for n minus 1 distinct objects taken R at a time. But we can read this n minus 1 PR differently. We can read it as number of permutations of n distinct objects taken R at a time without containing a particular element. Therefore, the total number of permutations is equal to number of permutations without containing a particular element plus number of permutations which always contain a particular element. So we have seen few results based on these things. And we have solved few problems on the expansion of NPR. Okay. Before looking into the problems, let me recall this for you. In how many ways we can arrange the letters A, B, C? So this one we have discussed. The number of ways is equal to 4P4, or else you can just write it as 4 factorial. And we have seen this one also. In how many of them all ABC, all these letters ABC come together. So whenever you see the constant like coming together, what you have to do is you have to tie up ABC. If you tie up ABC, then we have two units. ABC is one unit and D is the other unit. Therefore, the number of ways of the number of arrangements in which ABC come together is equal to 2 factorial times 3 factorial. So why we have this 2 factorial is we can arrange these two units in 2 factorial ways. And we can arrange ABC in this one unit in 3 factorial ways. Therefore, the total number of arrangements is equal to 2 factorial times 3 factorial. So you should not forget this problem. So basically in permutations and combinations we will have quite a number of problems. But all those problems can be boiled down to few similar problems. I repeat, number of problems will be more, but kinds of problems will be less. Okay, so before going into the main problem, let us understand this one. In how many ways we can arrange 4 people in 7 different chairs or 7 chairs? So we have 4 people and we have 7 different chairs. Now, in how many ways we can arrange these 4 people in 7 chairs? So we have 7 chairs and 4 people. The first person has 7 options. I can fill the first person in 7 ways. And similarly, I can fill the second person in 6 different ways. After filling the first person in 7 different ways, one chair will be occupied. I will be left with 6 more chairs. Therefore, I can fill the second person in 6 ways. I can fill the third person in 5 ways. So why 5 ways means after filling these 2 people in 2 chairs, we will be left with 5 chairs. So the third person can be filled in 5 ways, the fourth person can be filled in 4 ways. Therefore, the total number of ways in which these 4 people can be filled in 7 different chairs is equal to 7 times 6 times 5 times 4, which I can write it as 7p4. So I repeat, Here we have 4 people and 7 chairs. The question is, in how many ways I can arrange these 4 people in 7 chairs? So I can fill the first person in 7 ways. And I can fill the second person in 6 ways, I can fill the third person in 5 ways, and I can fill the fourth person in 4 ways. Now the total number of ways of completing the task, or number of ways of arranging these 4 people in 7 chairs, is equal to 7 times 6 times 5 times 4, which is equal to 7p4. So we are going to use this result in the next problem. Next we have an interesting problem. So many people make mistakes in understanding this problem, so I encourage the students to spend some time on understanding this problem. Okay, so first let me read the problem. In how many ways we can arrange 6 boys and 6 girls in a row? In how many of these arrangements all the girls are together? No 2 girls are together. Boys and girls come alternatively. Boys and girls sit alternatively. So they have asked us to find out these 3 arrangements. So in order to understand these 3 arrangements, let me write one more arrangement, or one more kind of arrangement. All the girls are not together. So now we have to address these 4 problems. So the first one is all the girls are together, and the second one is all the girls are not together, and the third one is no 2 girls are together, and the fourth one is boys and girls occupy alternatively, or boys and girls sit alternatively. So first let us write down the information that we have. We have 6 boys and 6 girls. So total we have 12 people. If there are no constraints, then we can arrange these 12 people in 12 factorial ways. Because we can arrange ABCD in 4 factorial ways, so here also we can arrange these 12 people in 12 factorial ways if there are no constraints. Okay, now let us understand these 4 constraints by some 4 positions. So let me give an example for this first condition. All the girls are together. All the girls are together, we can have this arrangement: boy, boy. 1, 2, 3, 4, 5, 6 girls are together. So this is an arrangement in which all the girls are together. Now, all the girls are not together. We can have one example where all the girls are not together. Boy, boy. 1, 2, 3, 4, 5. 3 boys and then now this is an arrangement in which all the girls are not together, because 5 girls are together and 1 girl is not together. I mean, we have 1 girl which is not sitting with these 5 girls. Therefore, this is an arrangement in which all the girls are not together. So all the girls are not together means girls are not sitting alternatively. If I say that all your family members are not together, then what you can understand is at least one person is out of station. Okay. Now let us look into the third constraint. Third constraint is no 2 girls are together. No 2 girls are together. So let me give an example for this one. Girl, boy. Girl, boy. Girl, boy. We have 3 pairs. 4th one. 5th one. And this one. So this is an arrangement in which no two girls are together. But you notice that there are two boys which are who are sitting side by side. But none of the girls sit beside a girl. So this is an arrangement in which no two girls are together. Now let us come to the last one. So boys and girls occupy sit alternatively. So we have boy girl 2, 3, 4, 5 and 6. So in order to understand these statements, you can look into these arrangements. So in the first statement, we have all the girls are together. So all the girls are together means all the girls should sit together. The second one is all the girls are not together. So what do you mean by all the girls are not together means at least one girl should be away from the group. If all the girls sit, if all the positions of the girls are scattered, then also we can say that all the girls are not together. But all the girls are not together means it is sufficient that one girl is away from the group. Now, coming to the third one, no two girls are together. No two girls are together means all the girls should be scattered. So this is an arrangement in which all the girls are scattered. So no girl is sitting beside a girl. Now, but in this position we have two boys who are sitting side by side. Now we have to address the fourth one. In the fourth one, boys and girls sit alternatively. So this is an arrangement in which boys and girls sit alternatively. So no boy can sit beside a boy and no girl can sit beside a girl. So these are the examples for this one. But they are not asking us to give a few examples. They are asking us to find out how many such arrangements are there. Okay, we can answer this problem one by one. So on the whole there are 12 people. We can arrange these 12 people in 12 factorial ways. So this is the total number of arrangements in which we can arrange boys and girls without any constraints. Now let us look into the first constraint. So what is the first constraint? All the girls are together. So you know how to solve this one. So whenever we have a constraint like something, all the girls are together, what we have to do? We have to tie up all the objects which are supposed to stay together. So now what we can do is tie up all the girls. If you tie up all girls, then what happens? We have 6 boys. 1, 2, 3, 4, 5, 6 boys. And then we have 6 girls. 1, 2, 3, 4, 5, 6. So on the whole we have 7 units. 7 units of people. So these 7 units of people comprise 6 individual boys and 1 unit of girl. Now we can arrange these 12 people. 12 people in the sense we can arrange these 7 units. We can arrange these 7 units in 7 factorial ways. But in this one unit we have 6 girls. These 6 girls can be arranged among themselves in 6 factorial ways. But in the unit consisting of girls, girls can be arranged in 6 factorial ways. Therefore, total number of arrangements is equal to total number of arrangements in the sense total number of arrangements in which all the girls are together is equal to 7 factorial times 6 factorial. So these are the total number of arrangements in which all the girls are together. Now let us look into the special condition which I have written down. All the girls are not together. All the girls are not together means total arrangements minus number of arrangements in which all the girls are together. All the girls are together. So this implies we have total is 12 factorial minus 7 factorial times 6 factorial. The total number of arrangements is 12 factorial without any constraint. Because we have 12 people, these 12 people can be arranged in 12 factorial ways. Now, all the girls are together means we have to tie up all the girls. If you tie up all the girls, we can have 7 units of people. We can arrange these 7 units of people in 7 factorial ways. And in this one unit consisting of 6 girls, we can arrange them in 6 factorial ways. Therefore, the total number of arrangements in which all the girls are together is 7 factorial times 6 factorial. Now let us answer this special question. The special question is all the girls are not together. All the girls are not together means total number of arrangements minus the number of arrangements in which all the girls are together. So which is going to be 12 factorial minus 7 factorial times 6 factorial. So now we have addressed the first two problems. Let us address the third one. Third one in the sense in the textbook it is just second one. So no two girls are together. So no two girls are together means first we have to arrange boys. So whenever we have a constraint like this, so first we have to address this constraint. The constraint is no two girls are together. That means girls should be separated by boys. So first we arrange these boys, or else first, okay, we can arrange 6 boys in 6, 1, 2, 3, 4, 5, 6. So we can arrange these 6 boys like this. And then after arranging 6 boys, we have 7 different positions. So we can place girls in any one of these 7 positions, or we can place the girls in these 7 positions. Therefore, the total number of arrangements is equal to number of ways in which we can arrange boys and number of ways in which we can arrange girls. So here the task is divided into 2 parts. T is equal to W1 and W2, where W1 is arranging boys, this we can do in 6 factorial ways. The simplest coordinate of W1 is equal to 6 factorial. Now W2 is to arrange girls in these 7 positions. Now we have 6 girls and we have 7 positions. I can arrange these 6 girls in 7 positions in 7p6 ways. Because we have seen if there are 4 people and 7 chairs, we can arrange them in 7p4 ways. So here we have 6 people and 7 chairs. Therefore, we can arrange them in 7p6 ways. W2 is to arrange these girls in 7 places. This we can do in 7p6 ways. Therefore, the total number of ways of completing the task is equal to number of ways of doing W1 times number of ways of doing W2, which is equal to 6 factorial times 7p6. So these are the total number of arrangements in which no two girls are together. So whenever we have a problem like this, no two girls are together or no two particular objects are together, then first what you have to do is first we have to fill the remaining things, leaving one place alternatively. So if you fill all the boys, then we'll have 7 different positions. We can fill these girls in these 7 different positions so that no two girls occupy side by side, or no two girls are placed side by side. So these boys can be arranged in 6 factorial ways and these girls can be arranged in 7p6 ways. Therefore, the total number of arrangements is equal to 6 factorial times 7p6. Now we have to address the last one. So the last one is boys and girls come alternatively. Boys and girls sit alternatively. So boys and girls sit alternatively means we can arrange boys in even positions and girls in odd positions. Boys in even positions, girls in odd places, or boys in odd places, girls in even places. So on the whole we had 12 positions. So first let us see this one, boys in even places. Boys in even places means boys in 2, 4, 6, 8, 10, 12 places. We can arrange boys in these places in 6 factorial ways. Now girls can occupy 1, 3, 5, 7, 9 and 11. So these girls can be occupied in, these girls can be arranged in 6 factorial ways. So let me write an arrangement here, boys in even places and girls in odd places. That means it can start with girl, boy, 1, 2, 3, 4, 5 and 6. By what we mean by saying boys in even places and girls in odd places means we have an arrangement like this. Now look, coming to this one, boys in even places and girls, boys in odd places and girls in even places. Boys in odd places means boys in 1, 3, 5, 7, 9, 11. We can arrange these boys in these odd places in 6 factorial ways. Now girls in even places, 2, 4, 6, 8, 10, 12. This we can do it in 6 factorial ways. So here we can start with a boy, boy, girl, 3, 4, 5, 6. So here the task can be performed in 2 formats. The first format is we can arrange boys in even places and girls in odd places. Or else the second format is boys in odd places and girls in even places. So the first format can be performed in 6 factorial times 6 factorial ways. This can be arranged in 6 factorial times 6 factorial ways. Now this work can be done in 6 factorial times 6 factorial times 6 factorial ways. Therefore, the total number of ways of arrangement total is equal to 6 factorial plus 6 factorial times 6 factorial plus 6 factorial times 6 factorial, which is equal to 2 times 6 factorial times 6 factorial. So these are the total number of arrangements in which no two boys and no two girls are together. So you may have noticed that whenever end comes, we have a multiplication. Whenever R comes, we have addition. Let us look into the next problem. Find the number of 4-letter words that can be formed using the letters of the word miracle. How many of them begin with an vowel, begin and end with an vowel, end with a consonant? So first let us write down the letters of the word miracle. So we have 7 distinct letters. So since the problem is related to vowels and consonants, first let us pick up the vowels. So what are the vowels that are present here? M is not an vowel, I is an vowel, R is not an vowel, A is an vowel, C, L are not vowels, and E is an vowel. So these are the 3 vowels that we have. And the remaining words are remaining letters are consonants. So what are the letters that we have remaining? M, R, C, L. These are the 4 consonants. Now, how many 4-letter words that can be formed? So I think you can directly write down the answer for here. 4-letter words is equal to 7P4. Because we have 7 distinct letters and we have to form 4-letter words, which can be done in 7P4 ways. Now let us answer the first one. So what is the first one? Begin with an vowel. So we have these 4 blanks, 1, 2, 3, 4, or these 4 places. We have to fill the first place with an vowel. So let us divide this task into 2 parts, W1 and W2. So W1 is to fill the first place with an vowel. So we can fill the first place with an vowel in 3 ways. So after filling the first place with an vowel, we will be left with 4 consonants and 2 vowels. So we will be left with 6 letters. So W2 can be performed in 6P 3 ways, and W1 can be performed in 3 ways. Therefore, the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is equal to 3 times 6P3. Now the second one, begin and end with an vowel. So here we have 4 places. I am dividing this task into 2 groups or 2 works. So this is my W1. W1 is to fill the first and last place with an vowel, and W2 is to fill the remaining places with the remaining letters. So W1 can be performed in 3P2 ways. So why we have this 3P2? Because we have 3 vowels and 2 we have 3 vowels and we have to fill those 3 vowels in these 2 places. So this can be done in 3p2 ways. So after completing W1, W2 can be done in. So once we fill this first and last place with an vowel, we will be left with one more vowel and 4 consonants. Therefore, the number of letters that are left is 5. And we have to fill these 2 places. Therefore, W2 can be performed in 5p2 ways. Therefore, the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is going to be 3p2 times 5p2. Okay. Next, the third one, end with a consonant. So here the constraint is we have to fill the last blank with a consonant. So W1 is to fill the last blank with a consonant, W2 is to fill the remaining 3 blanks. Since we have 4 consonants, W1 can be performed in 4 ways. So after filling the last blank with one of the consonants, we will be left with 3 vowels and 3 consonants. So total we have 6 letters which are left out, and we have to fill these 3 places, which we can do in 6p3 ways. Therefore, the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is equal to 4 times 6p3. The next problem is like this. Find the number of ways of permuting the letters of the word picture so that all the vowels come together, no 2 vowels come together, the relative positions of vowels and consonants are not disturbed. So I think you can understand the first 2 parts easily. All the vowels come together means what you have to do is you have to tie up all the vowels and then we have to arrange. No 2 vowels come together means first we have to fill up the consonants and then the remaining gaps with vowels. The third one, the relative positions of vowels and consonants are not disturbed. So the meaning of this one is the position of vowels should be replaced with vowels, and the position of consonant should be replaced with consonants. So in the position of vowel we should not fill a consonant, in the position of consonant we should not fill the vowel. So this is the explanation of this question. Let us look into the solution. So first thing what you have to do is we have to list down what are the letters of the word picture. So P, I, C, T, U, R, E. So how many letters we have? 7 letters. So in these 7 letters, what are the vowels? So the vowels here are I, U and E. So let us write down what are the vowels that we have. I, U and E. These are the 3 vowels. And the remaining 4 are consonants. So what are the consonants that we have? P, C, T, R. These 4 are the consonants. These 3 are vowels and these 4 are the consonants. Okay. So in how many ways we can permute the letters of the word picture? So number of ways of permuting the letters of the word is 7 factorial. Number of ways of permuting is equal to 7 factorial, because we have 7 letters and we can arrange these 7, we can permute these 7 letters in 7 factorial ways, because the number of ways of arranging A, B, C, D is equal to 4 factorial, because we have 4 letters and we can arrange them in 4 factorial ways. So here we have 7 letters, we can arrange them in 7 factorial ways. Now coming to the first one, all the vowels come together. So whenever you see a constraint like coming together, what you have to do is we have to group all the vowels together. So once we group all the vowels together, we have Okay, so what are the vowels we have? Tie up vowels. So now we have 5 units. So why we have these 5 units? Because we have 4 consonants. We have 4 consonants and 1 unit consisting of vowels. Therefore, the number of arrangements is equal to number of arrangements is equal to 5 factorial times 3 factorial. So we can arrange these 5 units in 5 factorial ways, and we can arrange this 1 unit of vowels in 3 factorial ways. Therefore, the total number of arrangements is equal to 5 factorial times 3 factorial. Now coming to the second one. No two vowels come together. No two vowels come together means, so in the previous problem we have done, we have done similar kind of thing. No two girls come together. No two girls come together means what we have done, we have first arranged the boys. So here no two vowels should come together. So what we have to do, we have to first arrange the consonants. So how many consonants we have? 4 consonants. 1, 2, 3, 4. So after filling the 4 consonants, we will be left with 1, 2, 3, 4, 5 places. So W1 is to arrange consonants. This can be done in cardinality of W1 is equal to 4 factorial, and W2 is to arrange vowels in the 5 gaps. So this can be done in 5p3 ways. Therefore, the total number of ways of completing the task is equal to 4 factorial times 5p3. Now let us move to the third part. The relative positions of vowels and consonants are not disturbed. So in the letters, so we have this picture I. So second position, the last position, and the fifth position. These are the 3 positions which are occupied by vowels, and the remaining positions are occupied by consonants. So what we have to do is we have to arrange these vowels among themselves. So this we can do it in 3 factorial ways, because we have 3 vowels in these 3 places. This we can rearrange them in 3 factorial ways, and we have 4 consonants. So I can arrange these 4 consonants among themselves in 4 factorial ways. Therefore, the total number of arrangements is equal to 3 factorial times 4 factorial. Number of ways of permuting vowels is equal to 3 factorial. Number of ways of permuting consonants is equal to 4 factorial. Therefore, total is equal to 3 factorial times 4 factorial. So we have to permute vowels and we have to permute consonants. We have to permute vowels among vowels and among the positions of vowels, and then we have to permute the consonants among the consonants positions. So this is all about this problem. Next we have this rank problem. All the problems of this kind will come under the umbrella of rank problem. So there are quite a few problems. So in order to solve all those problems, first we have to understand this problem. So let me explain the statement of the problem for you. If the letters of the word prison are permuted in all possible ways and the words thus obtained are arranged in dictionary order, then find the rank of the word prison. So what they are saying is, we have this word prison. Now we have to arrange, so we have these 6 letters in this word. So we have to permute these 6 letters. And I can permute these 6 letters in 6 factorial ways. So that is equal to 720 words. So we'll have 720 words. Now what they are asking us to do is, we have to list down these 720 words in dictionary order. After listing down these 720 words in dictionary order, we have to look for the word prison. And the position where prison stands is called as the rank of the word prison. Okay. But it is not possible for us to write down all these 720 words. So we have to develop a technique to find out the rank of the word prison without actually listing down all the letters of the word or all the words, all the permutations of the word prison. Okay. So first thing what you have to do here is, you have to write down the letters of the word prison in dictionary order. So the letters of the word in dictionary order is going to be I, after that we have N, after that we have O, after that we have P, and after that we have R, and after that we have S. So if you have a dictionary in which all the words will contain only these letters. Suppose that you have a dictionary in which contains only the words which contain, which are comprised of these 6 letters. Now we have to search for this word prison. So if I want to search for this word prison, I can directly go into the page which begins with P. So before I go into the page which begins with P, I have to count how many words are there which begin with I, which begin with N, and which begin with O. So this dictionary will have pages. The first page contains all the words which begin with I, the second page contains all the words which begin with O, and the third page contains all the words which begin with, the second page contains all the words which begin with N, the third page contains all the words which begin with P. First page contains all the words which begin with I, second page contains all the words which begin with N, third page contains all the words which begin with O, fourth page contains all the words which begin with P, and the fifth page contains all the words which begin with R, and the sixth page contains all the words which begin with S. So in this dictionary we have only these 6 pages. Okay. Now we have to search for the word prison. I cannot search for this word prison in the first page, second page, and third page, because the first page begins with I, the second page begins with N, and the third page begins with O. So I can directly jump into the page which starts with P. So before jumping into the page which starts with P, I have to count how many words are there in these 3 pages. So that is how many words are there in the first page, in the second page, and third page. So let us write down how many pages are there here, how many words are there here. So first try to answer this one. Number of words beginning with I. Beginning with I means I have to fill the first letter with I. After that we have 1, 2, 3, 4, 5. These 5 blanks. These 5 blanks, and we have 5 letters. Therefore I can fill those 5 letters in these 5 blanks in 5 factorial ways. Therefore number of words which begin with I is going to be 5 factorial. So similarly we'll have 5 factorial words in this page, in this page, in this page, in this page, here and here. So which begin with N is going to be 5 factorial. Number of words which begin with n is 5 factorial. Number of words which begin with O is also 5 factorial. So definitely these three 5 factorial words are there before prison. Suppose that you are in a cinema hall in 4th row and each row contains 20 people. So what is your ticket number if I ask? Definitely it is not going to be from 1 to 60. Because already there are 3 more rows before you and each row contains 20 people. So definitely your ticket number is not going to be between 1 to 60. So your ticket number will be in between 61 to 80. So here also the rank of the word prison is not going to be from 1 to, is not going to be the first 5 factorial, the second 5 factorial and the third 5 factorial. So it will be in the fourth 5 factorial. So it will be in the page which begins with P. So now what we do is we'll further divide the page which begins with P. Now I am dividing this page. I am dividing the page which contains P. So how I am doing is after P, after fixing the letter P, so the next dictionary letter is going to be my I. I will have all the words which begin with PI. I will have all the words which begin with PN. I will have all the words which begin with PO. And after that I will have all the words which begin with PR and all the words which begin with PS. Our required word prison is in this box. I cannot search for the word prison here. Here in the sense, here the first 2 letters are going to be P and I. So I cannot search for this word prison in this box. Similarly, I cannot search for the word prison in this box, and similarly I cannot search for this word prison in this box. I can search for the word prison only here in this box. This is our main target. So how many words are there before coming into this box? So before coming into this box means how many words are there which begin with P and I. There will be, so once you fix the first 2 blanks with P and I, we'll have these 4 blanks left out. So I can fill these 4 blanks in 4 factorial ways. I can fill these 4 blanks in 4 factorial ways. So there are 4 factorial words which begin with PI. Similarly, there are 4 factorial words which begin with PN. There are 4 factorial words which begin with PO. So before coming into this box, we have these 3 boxes. So in each box we have 4 factorial words. So there is no need to write down all the 4 factorial words here, here and here. Our required word prison is there here. So now what we have to do is we have to write down all these 4 factorial words which begin with P and R. And still writing down all these 4 factorial words which begin with P and R is also a laborious process. So we have this I, N, O, P, R and S. Already I have used P and I have used R. So the only letters that I have left is I, N, O and S. So these are the letters which I am left with. So with these 4 letters I can form 4 factorial words, that is 24 words. Now here I cannot list down all these 24 words, still I am lazy. So what I will do is I will further divide this one. I will further divide this one in the sense I will write down all the words which begin with PRI because I is our first letter. I will write down all the words which begin with PRN. I will write down all the words which begin with PRO. I will write down all the words which begin with PRS. So here how many words will be there? So here we will have 3 factorial words, here we will have 3 factorial words, here we will have 3 factorial words and here we will have 3 factorial words. Our required word prison is not there in these three boxes. Anyway, these 3 boxes will come after the box which contains the letters with PRI. So I will not care about these things. I'll be careful with this one only. So I'll be bothered with only this box. This box, in the sense, I'll be bothered with the words which begin with PRI. So here I'll have 3 factorial words. So 3 factorial words means 6 words. I will not write down those 6 words also. So I will stop at PRI. So after fixing I, so what are the letters that are left with? N, O, S. After fixing I, the letters that are left with are N, O and S. Now let me write down all the words which begin with P-R-I-E-N. All the words which begin with P-R-I-O. And all the words which begin with P-R-I-S. Our required word prison will not be there in this box, it will not be there in this box, will be there in this box. So before coming into this box, so we have to count how many words are there in these 2 boxes. So how many words are there which begin with P-R-I-N? So I have fixed the first 4 blanks. So there will be only 2 blanks left out. So it will be equal to 2 factorial. So here also there will be 2 factorial words which begin with P-R-I-O. So definitely these 4 words are going to be before the word prison. Now coming into this one, P-R-I-S. So what I have to do is I will fix this S also. So after fixing this S, what are the letters that are left with? N and O. So here the 2 letters are going to be P-R-I-S-N-O, that is my first letter, and P-R-I-S-O-N, this is my second letter. So this is my actual word prison. So the number of words which are there before this one is this one, 1. So the total number of words which are before prison is going to be, first what we have to do, we have to see in which page this word prison is there. So it is going to be there in the 4th page. So I have to count how many words are there before this page. So there are 3 pages, and in each page we have 5 factorial words. So after coming into this page which starts with P, what I have to do is I will divide this page starting with P into further divisions. So the first box contains the words which begin with PI, the second box contains the words which begin with PN, the third box contains the words which begin with PO, and the fourth box contains the words which begin with PR, and the fifth box contains the words which begin with PS. Our required word prison is there in this box which starts with PR. So before going into this box, we have to count how many boxes are there before this one and how many words are there in these 3 boxes. And in each box we have 4 factorial words because we are fixing the first 2 letters, therefore, so we will have to fill these 4 letters. We have to fill these 4 blanks. So we can fill these 4 blanks in 4 factorial ways. Therefore, there are 4 factorial words in this box, and this box. So coming to this one. So the words which begin with PR. So our required word prison is there in this box. So what we do is here we will further divide this box. How we are dividing this box? This box can be divided like this. Words which begin with PRI, words which begin with PRN, words which begin with PRO, words which begin with PRS. But our required word prison is there in this box only, PRI. So here I have to be a little bit careful, and what I will do is we will further divide this box. So we can further divide this box like this. All the words which begin with PRIN, all the words which begin with PRIO, all the words which begin with PRI, S, and so on. So our required word will not be here and will not be here. So our required word will be here only. All the box which begins with PRIS. So here we have 2 factorial words, that means 2 words. So what are those 2 words? PRISNO, that is our dictionary order, that is the first word, and the next one is our required word. So on the whole, how many words are there before this word prison? So this is INOPRS. First page, second page, third page, fourth page, fifth page, and sixth page. So our required word is there in this page. So there are 5 factorial plus 5 factorial plus 5 factorial plus. So this page we have divided into partitions. After doing the partition, the first partition is PI, PN, PO, and PR. So there are these 3 boxes before this one. So we'll have 4 factorial plus 4 factorial plus 4 factorial words before the actual word prison. So here also what we do is we'll further divide this one. How we are dividing this one? PR, and the dictionary order is I, and the next one is PRN, PRO, and PRS. But our required word will begin with PRI. So I will fix these first 3 letters. After fixing the first 3 letters, what we can do is we will further divide the box containing PRI. PRIEN, all the words which begin with PRIN, all the words which begin with PRIO, and all the words which begin with PRIS. So sorry, here we can have yes, okay. So our required word cannot be here, and required word cannot be here. Our required word will be here. So there are 2 factorial words here, there are 2 factorial words here. So plus 2 factorial plus 2 factorial. So this prison, what we can do is we can further divide it like this. PRISNO, this is your first letter, and PRISON, this is your next letter. So plus 1 factorial plus 1. So if you add up all these things, that is going to be the rank of the word prison. So here I have listed down that one. So what we have to do is, you can directly write down these statements. How we can write down directly these statements, let us see. So first thing what you have to do is, we have to write down the words in dictionary order. INOPRS. So the required word will be in 4th page. So there are 3 more pages before this one. So the first page contains all the words which begin with I. There are 5 factorial words which begin with I. There are 5 factorial words which begin with N. There are 5 factorial words which begin with O. So we will stop here. After that, what we do is we will further divide this page containing P. So how we will divide this page containing P? The page containing P can be divided like this. Number of words which begin with PI, number of words which begin with PN, number of words which begin with PO, number of words which begin with PR, and number of words which begin with PS. I will not count how many words are there with PI which begin with PA. I will not write down all the words which begin with PI, with PN and PO. I am interested in the words which begin with P and R. So there are 4 factorial words which begin with PI, there are 4 factorial words which begin with PN, there are 4 factorial words which begin with PO. So these things also I have to count. So basically what we do is we'll divide the page. Our required word prison is there in the 4th page. We have to count all the words which begin, how many words are there before that one. So once you hit this page which starts with P, you have to be a little bit careful. We'll further divide this page into boxes. Each box contains 4 factorial words, and our required word will be there in this box which begin with PR. So here 4 factorial means 24. I cannot list down all these 24 words. Here also I will do this partition. So our required word can begin with PRI, PRN, PRO, PRS. These are the partitions. Our required word will begin with PRI. So I will not care about these things. Here we will have 3 factorial words. 3 factorial means 6 words. I cannot write down these 6 words here. So I will further divide that one. PRIN, PRIO and PRIS. Our required word is here. So there are 2 factorial words here and there are 2 factorial words before this one. So on the whole we have 5 factorial plus 5 factorial plus 5 factorial plus 4 factorial plus 4 factorial plus 4 factorial. So after coming here we have this 2 factorial plus 2 factorial. So we'll write down those 2 factorial plus 2 factorial, and then we have this one PRIS. So with this PRIS we have these 2 letters or 2 words. So PRIS NO and PRIS ON. So our required word is this one PRIS ON. So here I have listed down those things. Therefore rank of the word is equal to this one. So no need to expand all these things, we can just write it as like that.